Hi, friends. Welcome again to another episode of Beyond the Clouds, Edge to Edge Transformation. This transformation is literally worldwide. Many different geographies are coming together to make this transformation possible. Among the people I got to know is Zvi Or-Bach. Zvi, tell us about you. How did you become the Zvi we know today?
I grew up in Israel. I was lucky to be given the option to do my bachelor degree in EE engineering at the Technion prior to going to the army. And when I joined the Israel army, I joined as a technical officer. And during 5 years serving the Israel army as a technical officer, I had also the opportunity to do a master's degree in Weizmann Institute in computer science. That also gave me another opportunity to meet a US company which was at the time hustling to sell equipment to the Israeli army. During that introduction, the Israel army wanted to show to the US company, which is Honeywell, electro-optic system at the time, that we are not just native. So they showed them my work at the master degree, which I did through the army. It was image enhancement, real-time video image enhancement. At the time, it was something very unique. Maybe I was the first customer for video rate analog to digital converter. That work was so impressive that I was offered to work for Honeywell, and they brought me to work for them in the US. I work in Honeywell. It was not Silicon Valley. It was at the time the 128 belt, but that was a second hub of entrepreneur at the time. So I learned about startup and I got very excited with the idea. I had the opportunity to do moonlighting with a startup, doing some interesting work over there. And then another Israeli company came to the US. It was Elbit Computer, and they offered me to come back to Israel as a chief engineer. And some of the things that I recognized working at the startup was that if I ever want to do my own startup, I need to kind of build up my portfolio of achievement and maybe personal recognition so people will be able to trust me to lead a startup. So a chief engineer looked to be a good move for a relatively young engineer at the time. I was about 30 years old. I came back to Israel as a chief engineer of ground weapon system division of Elbit. In the company, I came up with the idea that led to my first company. Took a year to convince investor to fund it. Elron, which was the number one investor in Elbit, was the one that gave us the money. We started the company called Chip Express. Chip Express soon enough changed its strategy. So the initial idea was to sell machine to do laser micro machining of device for 1 day turnaround. In the process, we recognized that selling the machine might not be as easy as we hoped to. The challenge is quite significant, but changing to providing a service would work. So we changed the company orientation to offering a get a service 1 day turnaround, and we decided to move to the US, to the Silicon Valley. We started with a small facility in the Silicon Valley. At the time, we were also introduced to Japanese company who invested with us. So in addition to Elron, we had investment from a Japanese company, a company that invested in other Israeli companies like Cytex. And we started the company in the Silicon Valley, offering a service of 1 day turnaround. One of our first customer was Apple, and that was a good hit. Apple, at the time, was a very successful startup. They were at the Apple IIe daytimes, and they were running like crazy. So after successful prototyping with them, within 1 year, they did 50 prototypes with us, or 50 devices. That launched Chip Express to be a successful startup in the US. We've been 3 years in a row on Fast 50, so it was very fast growth. At some point of time, the investor decided that this engineer grown to be manager maybe have done the job, brought a company from zero to $40 million, and maybe we need to bring a different type of management to move a $40 million company to a $1 billion company. I think the driver force behind this effort was the US VCs that we brought in, which was Morgan Stanley. I believe that it's quite common within VCs in the US to replace the engineer CEO to a professional CEO. I left the company with a good term and with enough funding to start my follow-up company, which I called EASIC. I started EASIC soon after Chip Express. That was timing-wise the dot-com bubble. So raising money from friend and family or angel investor was really popular, and we got the money very quickly. We started to develop the company. Unlike Chip Express, which was about using a laser, in EASIC, we wanted to use E-beam. We created a structure to be called structure ASIC rather than gate array because the technology has moved forward. I think we were the first one to introduce structure ASIC at the time. With EASIC, first we had to go through the valley because the dot-com bubble, and all of a sudden raising money was almost impossible. So we had few years that we had to live, to be very lean and mean to survive. I had to stop paying my US team, but luckily I had an offshore team in Romania that was quite good and relatively bearable to finance myself. So I did fund the operation in Romania for about 4 years out of my own account to keep the company moving forward. And then 2005, we were able to engage with Vinod Khosla and KPCB to get funding from them. And we moved forward EASIC. Eventually, EASIC got sold to Intel, but I was not in the company because soon after Vinod Khosla joined the company, he ended up doing the same things that Morgan Stanley did before. He says, okay, good job, Zvi, so far, but maybe we should bring a professional guy to take the company forward. I left EASIC middle 2006. For a while, I said enough with that because every startup, you put your life in there and then to be pulled out is almost like having their kids taken away. So I spent time doing some other things like investing in real estate. The market went through some real shift downward 2007 to 2009. Another bubble burst. Playing in the real estate market was not a good position to be at the time. So I said, okay, maybe I should go back to do what I really understand better, and that technology. And I started a new company, New PGA, with the idea that if EASIC and Chip Express was alternative to FPGA, maybe just doing a better FPGA would be better concept. For years, FPGA has made progress, but the industry make also progress. The idea was that maybe using a 3D structure for FPGA will be a better concept. So the idea was relatively simple. FPGA have a user logic and programming logic. The programming is only used first time when you do prototype. In production, you don't really need it. So maybe we can do the programming in the top level and the user logic in the bottom level, have a 3D structure for prototype, and in high volume, strip out the top level, just keep the base level. A device that is very compelling as far as prototype, but then in volume, cost effective. I believe the idea is still good, but in the process of developing the idea, things happen. At the time, even thinking about doing transistor on top level seems to be crazy. There's a thermal budget, there's many other limitations. It looked like almost mission impossible. But taking in account that programming is a slow process and those transistors don't need to be tiny, maybe a very primitive top level can still do the job, and maybe that could be done. In the process of trying to find a way to do primitive transistor at the top, we end up finding a way to do really good transistors. So there, this is really fantastic. So maybe it's not just for FPGA, maybe everything should be done this way. But if everything should be done this way, then we cannot be a fabless company or product company. We need to be an IP company. We started the company in 2009, 2010. We changed direction, even changed the name of the company. We changed it from New PGA to MonolithIC, even changed the incorporating state. New PGA was incorporated in California, but an IP company may be better incorporated in Texas. We shifted the incorporating state to be Texas. We changed the name to MonolithIC, and we embark on a new journey, which is an IP company. In 2000, 2011, I believe, we thought we are ready. We went to present at Semicon West, and we were even happy to be chosen to be a candidate for Best of the West. I was sitting at the booth with people going by, sometimes have curiosity to ask me what we are doing, but nobody show interest. Clearly, we were too soon. In fact, we didn't give up. We went another year, and the result was the same. So we realized it's going to take time. So we kept on going. I must say that this time I decided not to take VC money. My exit from EASIC was good enough to allow me to fund Monolithic 3D. And this is what we've been doing. So for Monolithic 3D, we never took VC money. I'm probably lucky with that because Monolithic 3D took relatively longer. We now have about 300 patents, majority in US, but we have in other locations. We have developed multiple monolithic 3D technologies, and we've been heavily inventing and filing new innovation from 2000, let's say 9-10 to 2020, 10 years of continuously inventing and filing new invention. Strange enough, while what started our journey to 3D transistors was one technology, even early, we end up inventing about 3 alternative approach. Strangely enough, the better ways, simpler ways came later. So you would think that first you invent something simple like low-hanging fruit, and then you go to something complex. In our case, it was the other way around. There are much better ways to do it now. And we later invented better ways to do it and easier way. Maybe by doing the more challenging concept first, we created a foundation on which we will be able to come up with much simpler solution. Since 2013, we had made it very clear that we believe that way to do 3D integration will be using hybrid bonding. We, on our website, created unveiling the breakthrough path to 3D. Still took a few years. The industry is now, of course, shifting to 3D. And I believe AMD is now in volume production. YMTC, 4 years ago, started to use hybrid bonding in their 3D structure. And I believe the whole industry is going to start to use hybrid bonding as the way to move forward with Moore's law, achieving higher integration of transistor and devices, but not necessarily in the classic approach of just making the transistor smaller. In fact, way back in 2014, I wrote a blog that was published both at E! Times and Solid State magazine that 28 nanometer is the last node of Moore's law. So yes, we've been doing scaling since then, but not with the lower cost transistors. Lithography have pivoted to the point that any scaling now will be more expensive, but the need to integrate more devices is driving everybody to still do scaling, even if the cost is still moving up. So since 28 nanometer, the industry has not been able to maintain Moore's law in the sense of making it cheaper to do double store. It's not cheaper, but it is higher integration end up winning at the system level to justify doing chips that are not necessarily cheap. Those devices are expensive, and try to buy a A100 or H100 from NVIDIA and you realize how expensive a single device could be. But the performance of the system level justify it. And of course, NVIDIA has been very successful. But I believe that from now on, AMD was probably going to be a very successful competitor. So I think AMD is the first one to recognize that the path forward is 3D, and they've been moving forward. I mentioned YMTC before that on 3D NAND, but they are not the only one anymore. Western Digital in the last generation decided to use hybrid bonding too. And I think DRAM is going to go hybrid soon. Clearly, HBM4 is going to be hybrid bonding, but even the basic DRAM device is going to probably shift to hybrid bonding soon. So I think the industry is going to shift to 3D, and we are very happy that we've been early coming up with all those technologies, far more than just how to do 3D, because as soon as we finish coming up, writing pattern how to do 3D, we ask what else need to be invented. And the first question is, okay, if I do a 3D structure, how do I remove the heat from the 3D structure? Heat removal is a real challenge, much less of a challenge in a 2D device because the silicon is a very good heat conductor. So you have just one layer of silicon. The base silicon, the body of the device, is heat conductor, and you put the heatsink on that, and you are 99% already there of removing heat. If it's extreme case, maybe you need some water cooling. But fundamentally, you have transistor that generate heat embedded in a heat conductor device. Once you start to move to 3D, you lose it, and that will be a challenge. I, again, was lucky in a way to meet Professor Subhashish, Mitra Subhashish, in the Technion in one of his visits. And then we both came back to the Silicon Valley and we met, and we eventually wrote a paper that was published at IEDM in 2012 of how to remove the heat out of the device. And later on, we continue with other type of innovations that we pretty much sure that the industry eventually will adapt as the industry move forward to 3D.
Wow, that's an amazing story. I was a big fan of Chip Express when it came out. The speed at which you were able to churn out chips, as well as of eASIC and how well, before Vinod Khosla took over and it was sold to Intel. So amazing. Each time there was a paradigm shift. And now you're doing the same thing with monolithic 3D. What makes you go through this when you're doing a startup? When technology is a risk, business is a risk, raising money is a risk. What kind of attitude or values do you have that makes you go through this again and again?
There was a book about Israel being a startup nation. Doing startup is something that requires teams that are willing to take risks. And that's not common to the human nature. But if you grew up in Israel as a kid, risk is part of life. If you are trying to avert risk, how can you live in Israel? You grew up in a country that risk is part of the DNA, and being able to not just take risk, live with risk as part of your life, as it's part of the way you choose how to conduct your business life. I believe that the number one reason that Israel ended up becoming startup nation is that a lot of good engineers growing up in an environment with risk is kind of natural, had no problem to go and take the risk, while their counterpart in other location maybe have the same good idea, but would not necessarily risk everything to go startup. And I agree, startup is a very tough going. We read about the success, but for every success, there's about 100 or more failures. Those failures need to kind of wipe the shirt, clean hand, and jump again and start again. And maybe Chip Express was not a failure, but it was not the kind of success that I could retire. And eASIC maybe was, again, not a failure, but not kind of success that I could by mention, but I was able to take those success to build on them, to build the next startup. In a way, maybe doing the eASIC was an enabling to do the monolithic 3D. So I'm very happy with the blessing I got.
I've been through a few startups, and every time it grows to a certain stage, there's this belief that you need a professional CEO. It's like giving your baby away to someone.
I'll tell you my own rule of thumb. I believe that there are two types of startups. One is Brave New World, and one is Cheaper Better. For the Cheaper Better, you could be successful in finding new CEO because a Cheaper Better is in an industry, and that industry has executive that can recognize why the cheaper better is better and jump ship to the cheaper and better. But if you're looking to take a CEO to invest in a Brave New World, be very careful. Brave New World was most of the time extremely successful if the entrepreneur end up being the CEO all the way, whether it's Sony, whether it's LSI Logic, whether it's Google, Amazon. You pick a successful company, Facebook. If you see a really successful company, most of the time, if it's a Brave New World type company, then the founder was the CEO until it became unicorn. My advice to VC, both type of companies are worthy of investment. But with the Brave New World, please find a way to support the CEO because he is the one that has a vision to this new world, and he is the one that understands this new world, and replacing him with old world people will kill the company.
The DNA of the company revolves around the technical and the business founders, because they really know that this takes a huge leap of faith to change everything. The 3D chip was a good idea when you started, but it wasn't a quote unquote business need. And today it is a business need. You cannot scale without going 3D. If you keep scaling the way we've been doing, it's super expensive. So, what's your prediction? Do you think all chips, what you're saying is every DRAM, everything will go 3D? And do you think we'll be able to continue to scale after that as long as we take care of thermal properties and all that?
I'll put it within context of some very simple technical understanding. All devices, all electronic devices are constructed basically with wires and transistors. Now, transistors are getting really better, especially for a logic function, as they get smaller. Transistors for memory, transistors for logic are getting better when they're small. They consume less power, they switch faster, but the wires are not. So this is fundamental handicap of electronic system, interconnect. Then you need to be aware of another handicap of semiconductor industry. In this industry, we have a process that is getting really, really complex as we move forward. And with today's reality, the process to do logic transistor is completely different than the process to do 3D NAND, and is completely different than the process to do DRAM. And to build system, you need all of them. So what the industry has been doing in the past is take a PC board and do a device and connect them with a PC board. Here comes a PC board being primarily an interconnect fabric that becomes the weakest link of the chain. So interconnect is the weakest link of electronic system. And now you try to connect a transistor at the CPU through wires that will go to the edge of that CPU device, then through wires, whether they go 2.5D interposer or PC board, to the input of another device, which is a memory. And then from that edge to the internal where the bit is sitting, you have so long interconnect path, and unfortunately, so few wires, because how many wires can you take out of a device? If you're taking 1,000 wires out of a device, that device is extremely expensive. But what is 1,000 wires when you have millions of connections to do? So fundamentally, our classic way of building device is broken. We could push the end farther and farther by scaling. You look what people are building, and NVIDIA devices are radical size. And eventually you have to go out of the device. So if you still go to 2.5D or interposer, system level performance will be limited by that interconnection scheme. You go 3D, all of that disappears. So I believe the path forward is now clearly 3D. The beauty is that hybrid bonding is a very low cost process. Per level, it's about $10 to $20. And you get both the mechanical connection and the bonding. I believe that the die to wafer is kind of an intermediate step for the industry to evolve the architecture, because you have to change the architecture. Past architecture has been all around edge. You have a CPU and you transfer all the information to the edge, where they're going to go from that edge to the edge of the memory, and from that memory to the bit cell. So it was edge to edge. That's the architecture of a memory, that's the architecture of the CPU, that's the architecture of our system today, based on our interconnection approach today. You go 3D, the CPU or that core can directly talk with a memory bank on top of it, which will be maybe a micron apart instead of millimeter. Nothing can win against that. So clearly the architecture needs to change. And maybe instead of big CPU, many small CPUs, like GPUs, each one of them directly connected to its own memory. Yes, so architecture change will take some time. Industry have to evolve. And in the meantime, what AMD been doing was die to wafer and relatively simple architecture modification, not yet total system. Eventually, the whole system will change. And we got glimpse on that concept by a very interesting work that was published by Alibaba. They show how to change architecture and take hybrid bonding all the way through. And I believe eventually everybody will adopt it. And there are some signs that some people are already adopting it. In the longer term, I believe it will be wafer to wafer, which make it very, very low. And if you go wafer to wafer, then maybe on the big system, you don't dice it anymore. So just we know of Cell doing a wafer level device, but it's just one level. Go 3D and go wafer level, and you will get huge win. So you need to do what Rebus has been doing, which integrate redundancy. But why not? If your device is modular, you have GPUs, every core could be a redundant core. You have to integrate redundancy. Once you integrate redundancy, you can do wafer to wafer and multiple wafer integration, and I believe that's the way to go. The path forward is really exciting. 100,000 times better computers, just going with this type of integration, redundancy, heat removal, all those techniques that we've been publishing, and of course, filing as patent, sorry, but that's IP. And yes, there is potential scaling in that direction. If a device today, even a simple device, is 10 by 10 millimeter, if you go 10 millimeter upward, that gives you a lot of level. So bearing in mind, interconnect will be a limiting factor. As long as I'm not cube, I'm not optimized. If I'm not 3D, I'm not optimized. So there is a potential to do multi-level. I don't know how many, but clearly one processor may need multiple level of memory. Even one HBM today is 8, 12, and going to 16 level to support one GPU. Beyond that, you probably need 3D, and the 3D itself might be 200 level. All of a sudden, you can see a structure that look like we're shifting from the old world of cities of one floor to skyscraping. I was in Tokyo many years ago when Tokyo was mostly one floor, two floor, three floor. Go now, everything is like New York, like Manhattan. Everything is going high rising. So yes, I believe devices will go that same path. In the process, we will have to evolve architecture. We will have to develop heat removal techniques and many other schemes. Of course, redundancy will be a big thing with that. But doing so, I believe the path forward to do smarter, stronger computer is open, and the market has full appetite for transistors and computing.
In neural networks, one of the biggest challenges is what you are pointing out, data movement. Sparse matrices, each neuron does its own thing, but moving things, the interconnects can kill you. So do you believe that by using 3D, that problem is solved?
Absolutely. Solve is a big word. We are in the world of continuously improving. So yes, I think the win by doing the memory on top of the processor and making the memory in a close proximity to where the neuron is instead of being multiple millimeter apart, having it micron apart, would allow us to have many years of improvement, including something like 10x, 100, and 1000x. Beyond that, I don't think innovation stops, and something may come then to be the next horse to keep driving. If I look at what the industry can build today, we have a path forward that would allow us to do computers that are 1,000 times stronger than what we are doing. In fact, I mentioned Mitra Shubasic from Stanford. He and Philip Young and other people, Berkeley and MIT, have published even in 2015 how 3D structure could do computers that are 1,000x stronger. We wrote a full chapter about it in a book called Nanochip 2030, and we wrote a full chapter about how to use hybrid bonding to build computer that has a memory on top of the logic, and when every neuron kind of thing, every logic element talks directly with its own memory, therefore the whole architecture is very much like the mind, not like a computer today.
In terms of finances, your company has a huge portfolio, patent portfolio. So do you operate like an IP company? Is your revenue model by selling IP?
We were lucky enough to be able to sell few patents. At the time, it was not a public domain information, but if you look on the website, you can see those patents and now belong to Samsung. So we sold few patents to Samsung and made a nice income out of that. In the future, approach might be different and more like licensing. So we are now evolving to that direction. But of course, licensing is a broad term and there are many, many ways of doing it.
Besides thermal, do we have all the other design automation tools that are needed to go into 3D chips in a big way?
Like anything, the tool will evolve with the shifting of the industry. Clearly, AMD has shifted few products to the market, and they have done it with some tools. TSMC has a whole program to build tools to support some of their 3D fabric and announced collaboration with Synopsys and Cadence. Those tools will evolve as the industry will evolve. How many of those tools are now? There are some. And can the industry now jump immediately to the ultimate solution? Probably not. Like anything, it will be a shift. We will start to do first tool level, first maybe die to wafer, maybe without a lot of redundancy, maybe per function like the VRAM 3D cache of AMD, which did not require a lot of new tools. I think the industry is already gearing up to that. You can see Synopsys and Cadence heavily involved with 3D structure, both for thermal, and there are some other companies that are focusing on thermal analysis, but also design, architecture, everything. Those tools are evolving, and the industry have been able to build 3D NAND, and the industry will be able to build everything is needed. Manufacturing-wise, we have done far more complex stuff than what is ahead of us. Architecture-wise, it's new, but we also done a lot of architecture. The industry will evolve and go in that direction. The path forward is like any new path will require challenges.
You come from the startup nation. What advice would you give to people who want to do something on their own, but don't feel the courage because it's not easy to not have that paycheck to paycheck?
You ask me about advice on something that has to do not with logic, but with emotion. How can I talk to someone to be brave? I don't know. The courage is something that people have to find within themselves. If someone asks themselves, what type of risk do I want to take? A risk of going to work with startup, which may mean that I'm not going to get the biggest salary. So those risks are at the low side of life risks. So you take a risk of maybe not getting the biggest salary or the biggest title, or maybe fail a bit doing so, or going back after 20 years and kick yourself for not trying. And I think the risk of not trying going to haunt you more later on if you never tried. So if you have it in you to do something that you can, we work and we bring check home. And some people, for them, it's good enough. Some people consider the work as their life mission, their invention as part of their role in life, their creation as part of what they are to do in this world. So if you want a new position your work life at the highest level, then not taking the risk might haunt you later on because you're never going to be young again. That's for sure. So the risk to take is easier when you have less mouths to feed, let's say it like this. And jumping on an unproven way is easier if you don't need to leave a billion-dollar industry that you are commanding. If you're trying to do it later, you're probably not young. And it's still appropriate to do because maybe you already got enough money, why not take a risk? And if you are young, then it's easier because what are you risking?
Very true. That's the logic that led me into startups just 7 years into the industry. And I'm grateful. Not an easy path. It's a huge amount of work, day and night almost, but it transforms who you are. It becomes your life mission. Well, it's a joy talking to you, Zvi, and I hope you continue to do these things and maybe even support other startups. And I know you have, and support other companies.
I'm a chairman of a company called Semiconductors. I've been supporting other companies.
Yeah, it's exciting because once you have your own baby, you can help others have their own babies too. And it's such a joy to see you. You have the chutzpah of somebody who's still a teenager wanting to do new things every day. And do you think you'll continue doing this?
I've two other startups that I've filed patent for them. I've accumulated multiple patents. I'm trying not to spend money on them at this time because I want to focus on MonolithIC 3D. But I hope that as soon as MonolithIC 3D monetization get off the ground and the funding is there to do the other startups. So yes, I do have other innovations that I want to bring to the world.
Wow, I really like that energy. I've seen what Chip Express did to the industry, what EASIC did to the industry, and what your current company, MonolithIC 3D, is doing to the industry. So all power to you. It's exciting. And I'm so grateful I got this chance to talk to you face to face. It's exciting
We're going to
what you're
meet.
doing.
Thank you.
To people
Thank
out
you.
there, this is why I talk to different people from different regions. Some of us have higher risk appetite, some of us want to be in a steady state zone. But taking technology forward, all the stories you hear about ChatGPT or about new ways of doing things, for every one such company, there are 100 dead bodies. Companies did not succeed. But the ideas, the new ways of doing things get integrated somehow, and human progress is made. So please come forward if you have, again, crazy new ideas. May not be successful yet, but they will pave the way towards new ways of doing things. And hopefully, we'll be able to use all this towards human progress in a very meaningful way. Again, Zvi, such a joy talking to you. Toda rabah.
Thank you. It was pleasure meeting you, and I hope to meet you soon.